a dragon winding through a green, swampy area. Earth fill fell non-stop at the end of the conveying system and spread evenly over the fill area. With close synchronization between dump trucks and the conveyor belt, the swampland was gradually filled in. Before starting the earth fill operation, a magnetic extensometer system, settlement plate, and groundwater level observation apparatus were installed by the construction unit. Detailed measurements were taken and sent to China engineering consultants for settlement analysis. At borrow area number 6, excavation continued without stop. Excavation operations started from the top and gradually descended downward. Since the excavation depth of the borrow area was more than 130 meters, excavation was done step by step, forming a terrace. For construction safety, excavations were done every 24 meters downward. As many as 20 bulldozers were used in the operation at the number 6 borrow area. Workers and machinery could be seen scattered throughout the vast area. The whole operation was impressive, and morale among the workers was high. At the peak of construction, more than 500 retired servicemen were employed, and over 100 trucks were used in shifts during the 24-hour operation. The conveyor belt was controlled by a computer system to account for all the dirt moved. The system could notify operators of malfunctions and could automatically stop. At the end of the conveyor belt was a 151-meter auto-shift conveyor spreader loaded with 8 sets of tracks, which could make semicircular movements. By using this equipment, aggregate from the borrow area could be distributed evenly throughout the fill area as needed. In order to provide an area for factories and houses to be relocated into the area from the Artong floodway, 53 hectares were first completed. For construction of various public facilities and utilities in the preliminary stage, an additional depth of 1 meter of soil was added for preloading to accelerate earth settlement. Preloaded earth amounted to 540,000 cubic meters. Total landfill for the entire first section came to 260,000 cubic meters, while that for section 2, which has an area of 82 hectares, amounted to 406,000 cubic meters. The original soil within the swamp area of the industrial park was very soft and not of much use. Part of the mud underneath was excavated by the construction unit of this agency with excavators and moved out by trucks. Part of the mud was solidified by using mud treatment chemicals. Another part was dried in the sunshine and then mixed with aggregate for backfill. The installation of the giant conveyor belt as well as the use of dump trucks enabled the earth moving, earth filling, and grading operations to proceed smoothly. This project was accomplished through years of dedicated efforts by the retired servicemen. Even distribution of earth fill by the conveyor spreader further expedited the grading work of rolling by bulldozers and rollers. This helped to further reduce time and labor costs. Engineering quality of the project was also effectively controlled. An extra meter of earth was filled to accelerate settlement of landfill. This surplus of preloaded earth fill was removed when the fill material stabilized. Looking down over the industrial park, what was once a swamp area has become a broad, newly raised plain. During the construction period, in order to prevent erosion from the slopes, cover planting was undertaken immediately after excavation of each terrace. Landscaping of the mountain slopes was also done from the top and gradually proceeded downward. The entire conveyor belt system, which reached a total length of 1,600 meters, was all covered to prevent air pollution due to dust. This reflects all the efforts of the client, designer, construction unit, and supervision unit to invest both capital and manpower to prevent pollution from dust and noise. This large-scale earth fill operation was completed by the end of 1985. After the overall earth and residual settlement of the industrial park reached allowable stabilization limits, construction of the various public facilities followed immediately. A strict quality control was exercised, and integral planning design was adapted for this industrial area. Public facilities included a sewer system, water supply system, drainage, roads,